Let's see how this build your understanding problem went. We've got a bag containing one red marble, one blue, and one green marble, and we're going to consider the experiment. Take one marble from the bag. The sample space, and I hope you remembered to label that S and put the curly brackets around it, but the sample space is red, blue, and green. The event take a marble that is not red is E equals, and then we have the curly brackets. Now if we take a marble that's not red, that means we've either taken a blue one or a green one. Hopefully you're feeling fairly comfortable with the vocabulary. So let's turn back to probability. And I'm going to give you a formula for the probability of an event. And that formula is that the probability of an event E is, this is read N of E divided by N of S. And what this is referring to is the number of outcomes in the event, I'll just say in E, divided by the number of outcomes in the sample space S. By the way, this formula assumes, so we're assuming all outcomes are equally likely. Which is mostly what we'll be dealing with for quite a while. Now, these probabilities fall within a certain range. So to see why that is, let's realize that if an event E cannot happen, then its probability is 0%. Which of course we would usually write just as a decimal, and all we need is a 0 for this. If an event E must happen, in other words, there's no way it cannot happen, then the probability of that event E is 100%, which in decimal form is 1.00. Now you can't get less likely than 0%, nor more likely than 100%, which means the probability of any event is greater than or equal to 0, but less than or equal to 1. And I'll just make the note that the probability of the sample space, so if we think of the entire sample space as our event, the probability is 1. And we'll see in the next couple of examples why these things are true. So let's go on to our examples. So let's consider again the experiment roll a die with sample space S equals curly bracket. Oops, there's no 0 on a die. 1, 2, 3, 4, 5, 6. Close the curly brackets. What's the probability of rolling an even number? Well, this is talking about the event E, which contains the outcomes 2, 4, and 6. Now the formula we just got says that the probability of any event where all outcomes are likely, which they are in this sample space, is the number of outcomes in that event divided by the number of outcomes in the sample space. Now, the number of outcomes in our sample space, let's put that up here by the sample space, is 6. And the number of outcomes in this particular event is 3. So our formula says that the probability of this event is 3/6 which is 1/2, or of course, if you prefer a decimal, you can write that as 0.5 or 0.50. Now notice this completely agrees with what our intuitive idea of probability said, which is that if I'm looking at the probability of getting a 2, 4, or a 6, I have 3 chances out of 6 of getting an outcome that's in that event. What's the probability of rolling a 3? Well, this time we're talking about the event that contains only the outcome 3. So the number of outcomes in this event is 1. By the way, notice that n is a lowercase n. I don't know why we use a lowercase n here. It's just traditional. So let's do that so that our formulas are clear to anyone who might be reading a formula that we write down. Anyway, thinking back to our intuitive idea of probability, we would say we have 1 in 6 chances of getting a 3, so a 1/6 chance. But let's get our formula into action here. So the formula says number of outcomes in E divided by number of outcomes in the sample space. So we get that 1/6 that we were expecting. Now you might be wondering, if we already know how to do this, why are we bothering with a formula? But there's many times where it's not so intuitive coming up with a probability, and the formula will be extremely helpful. It will be a tool that we can always fall back on. One more in this example. What's the probability of rolling a number larger than 4? Well, now we're talking about the event containing the outcomes 5 and 6. So we should have, for our probability of E, that's uppercase P, parentheses, uppercase E, close parentheses, that should be 2 chances out of 6, 2/6. But let's use our formula for that to practice with it. It's going to be the number of outcomes in event E divided by the number of outcomes in the sample space. And of course, the number of outcomes in this event is 2. So we get the 2/6 that agrees with our intuition. And of course, we'll simplify that to 1/3. And as always, if you prefer to write this as a decimal, you can do that.